Okay, great. So, Assalamu alaikum to everyone. Uh, it's it's with great pleasure to introduce our honorable guest, Dr. Shahzad Cheema, who is joining us live from Munich, Germany. Dr. Cheema is an AI expert and advisor in the AI industry for the last 20 years. Currently, he's working in Germany. I think the detailed introduction, I will leave it over to Dr. Shahzad Cheema. Just between myself and Dr. Shahzad, we were, it was year 2014, 2016 when we were together in Bonn. Dr. Shahzad was doing his Ph.D. and I was doing my MS. So today Dr. Shahzad will be sharing his thoughts on the recent developments in artificial intelligence and its impact on our lives while moving forward. He will discuss the evolution and overall the landscape of AI along aspects such as technology, methods, use cases, processes, etc. On behalf of Emumba, we extend a sincere and cordial welcome to Dr. Shahzad Cheema. We deeply appreciate your presence, and it is indeed a privilege to have you joining us. Thank you very much, Dr. Cheema. Without any further delay, over to you, please.
Perfect. Yeah. Thank you very much, Fahad, for a very nice introduction. I will go more detail about my background later on, but first of all, thank you very much, everyone, for joining, and Emumba and your leadership team for having me here. It's really, really a pleasure and honor, and I hope we get something very interesting out of that. So maybe I can start by sharing my screen. Can you see my screen now?
Yes.
Perfect. So I think we will try to make it between roughly 40-ish minutes, and then we can have also, discussion and question answer session. So I think my talk is about AI, the current trends, challenges, and opportunities, and how it could affect us, especially the people in IT and IT related areas. How I have structured just a little bit of introduction of myself, and then some projects, because I have been working, for quite some time. So I think I will just, give some glimpse about some of my interesting projects. Then what are the current trends of AI? Also, then what are some challenges, and wherever there are challenges, there are opportunities. And maybe then at the end, we can also have a discussion and Q&A session, if you like. So to begin with, okay. So to begin with, as I said, it seems like quite old to begin. Like, I have 20 years of experience, but actually I started, I did mathematics, master in mathematics back in 2002. Then I did a master in computer science. I used to work at Punjab University in Lahore as lecturer for a few years. Then I came to Germany again. I loved, studying. So I did a third master degree, this time in robotics. So just to, make all my bases clear. And then I did a PhD in Bonn, where I also met Fahad. Later on, I worked in a startup from a company from Amadeus. This is a big data ad tech company related to traveling industry and hospitality. It's from 2015 to 2017. I worked at DHL, so it's a Deutsche Post DHL. Now it's renamed again to DHL Group. This is, I think, one of the largest companies in the world from the shipping, the largest in many aspects. And there I worked in the headquarters. So this was very interesting and unique experience, because DHL back in 2014-15 decided to make AI and data analytics as a corporate function. So we were working really in the departments of the CEO. So we had access to strategy, corporate development, and then we were also then responsible to work on first of a kind projects, and then bring this knowledge and expertise to different departments and create teams. Then in 2017, I moved to IBM Watson IoT headquarter. So IBM decided at that time to make IoT headquarter in Munich, Germany. So this is one of the, I think, the only IBM division that are headquartered outside the United States. And the reason is that this area of Germany, it's close to the Munich, close to the 500 kilometer around Munich. 60% of manufacturing or industrial products are there. So most, large automotive companies are around this area. There I worked as a lead data scientist. We developed an industry lab. We had, of course, all the time C levels, but we did quite many interesting projects there. Also, from my personal interest, I also used to be an academic ambassador for IBM and also later on quantum ambassador. In 2021, I joined Huawei, a Nuremberg Research Center. So Huawei has many research centers all over the world, and the Nuremberg Research Center is principally dealing with the digital power, energy areas such as data center, PV plants, and so on. So there currently I'm working as a lead AI expert. In the meantime, of course, I also love to contribute and engage with my home country and homeland in Pakistan. We have many collaborations, initiatives for mentoring, for developing. And thank you very much, Fahad, for also involving with Emumba and introducing us further to develop our collaborations. And that's also what I'm really looking forward, that how can we work together in future and bring, harness AI power together with the IT expertise such as your company. So, as I said, I will start with some example projects. And one of the areas that I have been working is robotics. And in robotics, because it was also my third master degree here, and I was working in a European project. So if we could divide them in different areas from robotics. And pardon me, I do not went into the definition of AI, what is AI and what it is not, just assuming that, it's the talk of the town. So for me, AI is principally making machines and system intelligent and making them behave in a way which is generally optimized for certain objectives. So robotics is one of those areas. And I would like to maybe show you a video first to just build the basis. This is something that we were working back in 2008. So in 2008, we were working on a robotics project, and the underlying idea was how to enable a robot to learn concepts. This is pretty different from what we see quite often now, that we want to have an input-output from a system. But here we are trying to see how a robot or a robotic system could develop certain concept learning. So what we did is that at that time, the robot is very slow and a small now robot. It's 2008. And the robot is trying to, we created different scenarios where it has to try to take different objects, and then it is trying to learn relation of those objects. For example, in this case, the robot is trying to learn some concept of stability of objects in the environment. Let me show you a small video too as a starter.
Shahzad, I hope there isn't any voice associated to this video, because at least I can't hear.
Oh, that's a shame. There is actually a voice associated to that. Okay.
Okay, maybe then we can't hear it.
Okay. Well. Okay, so let's do it without voice because voice makes it very interesting, and I don't know how to make it.
No problem. I think we can continue without voice as well.
Okay, just one thing I can try again is I can just try to share this one, and if you're not able to hear the voice, then maybe I can just comment. So what the robot is designed is to perform some predefined tasks, and those tasks are, picking up the objects, placing, getting closer to them. So these are the fundamental capabilities of robot, and the robot is trying to play with that and then try to build new concept. And in the beginning, when the robot is out of the box, it has just a very couple of basic concept, which is like I can move, I can get closer to the things, I can pick up the things are pickable, they are movable, and that's it. So this is kind of concept learning. And now the robot is saying, okay, what if I try to place objects on top of each other? And it put one object, and it learned that, well, I can place objects on top of each other. And now it's kind of picking now another object. And by doing so, again, it will kind of learn that if there is an object which is stable, like the box or these boxes, I can put another unstable, movable objects. Okay, it says it's boring, on one other object. And that this way, it could actually develop a certain concept, which is in this case, back in 2018, that concept was encoded as a decision tree. And later on, it tries to do some more things like that, for example. So now it's trying to put something on an unstable object. And as you can see, it will not work. So what is the thought process is building a kind of a automated decision tree that if I put something on top of one stable object, yeah. So, and that's kind of the way that we used to, let's say, do this type of concept learning. I hope you can hear me now properly?
Yeah, we can hear you. Yeah,
perfect. So, but this is let's say what we call really concept learning, curiosity, goals, objective, and that's not quite easy even today. That are some fundamental questions. So where we cannot say that we are done with that part, that is hard. During this project, we also learned that even common sense is actually the most difficult part. So if we ask the robots the difficult question, like, okay, from vision, robot has more sensor than human. Robots have, more capabilities in several scenarios, some scenarios, and most scenarios, actually, it has more capabilities for individual tasks, and it can perform pretty well. However, with those common concepts, like building new concept, having curiosity in itself, these are some challenging tasks that typically we have to encode. In the middle, you see another example of robotics. This is something that we typically use in smart home and offices. The example is from Now Robot, but the company has a new version of this robot. Maybe you will see also another couple of examples here. The capability of robotics is mostly for conversational, because the humanoid robots, they are not yet there that they could do a lot of service. So service robots then has to have a good mobility setup. On the right side, you see an example that I worked, I think in 2018 with the robot from ABB. And of course, we have other companies like KUKA. So these robots are industrial robots, typically single arm, but this is a special one with 2 arms. So what the companies are doing, these robots is, of course, for industrial automation. Often they have cameras.
Shahzad, I can't see your screen. If you are sharing the presentation, then probably we are not. Yeah, for us, this robot screen is
Yes.
there. Yeah, now
Is
it's
it
fine.
now?
Yeah,
Can you
yeah,
see?
now
Okay,
it's fine.
perfect.
Thank you.
So so this is the middle robot I was talking about is this, typical humanoid, nice looking robot which can do conversation. They are very good for educational purpose. Also on airports, we have applied them and hotels and so on petrol stations. On the right side are those industrial robots. This one is special. It's called Yumi from ABB. And we used to it for some sort of automation of industrial manufacturing, where you could show a certain design of a product, for example, a PCB board, and the robot could even learn directly without even being explicitly programmed that what is my job to do. How, given a board and a set of pieces, okay, I just have a vision and I figured out that this is what is going to be my production process for next step. So it's kind of imitating learning. In industries, these robots or such robots are used a lot. Not often with too much of, let's say, AI, but again with a lot of automation. So we have done in several cases certain improvements in these robots. So what else back I have been working also is in AdTech industry. So in AdTech industry, we want to optimize, as you know, in AdTech, like Google ads or even, on Facebook. This is one of the earliest industry responsible for advancements in big data and AI. And here I was working back in 2014 for this startup. Afterwards, I also have worked with some clients. So typical problem you have here is that how to optimize the ad revenue, how to maximize the click-through rate, and so on. So you have this typical supply side platform, which is getting those requests for ads from websites, from mobile games, and so on. And then you have demand side platforms where the advertisers have registers and they have different campaign logic and budget and everything. And your job, we were sitting sometime here, sometime around this engine where we are trying to optimize. So we are learning from this data. Even if you look into this whole technological revolution that came, especially the big data revolution, this was one of the earliest enablers of that, because then you need to use Hadoop, you need to use, for example, MongoDB, and you need to use technology that is capable of having, this type of, that would support this type of infrastructure where you have, for instance, millions of queries per second. And you have to complete this process and the whole logic and whole machine learning cycle within milliseconds, maximum 100 milliseconds, but now even less milliseconds. And so it cannot be that you have a bit of slow language. So often what we used to do is that we used to build the models and then we transform or ask the dev team to transform it into some other language and framework, like Kotlin and Go and so on. Also, there are then some machine learning models which are then slow. So you have to make sure that you are implementing the ones that can be highly parallelized and that could be highly efficient models. And you also have to decide whether the time, what are the trade-offs of applying a simple logic versus a complex one. Another area that I used to work is in logistic, and in logistic, we saw, this is an example from my work at DHL. So in DHL, then we had different problems. For example, one problem, typically, it's for any large organization, there is certain forecasting for demand of the customer, forecasting of your own probable production. If you are in energy domain, there is also typically the forecast of supply and demand. This is very common. And then on top of that, once you are able to forecast one thing, then you can decide optimal operations. You can minimize your cost and so on. So in this project, we wanted to build an automated forecasting system for 35 parcel centers in Germany. Every day, it's like 3 to 5 million packets that are being routed from one place to another place locally. What we did is it's a time series data. It's not a lot of data, and that's what you see on the right-hand side. That then we basically combine different data sets. Then we build multiple machine learning models. We kind of made an ensemble of different random forest. We also included what are the recent error, what is the human feedback based on our model's performance. So all of those are then combined as a late fusion model. Late fusion is where the system learns from its own performance over time, and then it provides the forecast. Of course, it was really, really a successful project, and it improved quite a lot for the forecasting. And then we hand it over, let's say, to our department, and a function was developed. One other interesting, and what from machine learning point of view, what we use here is random forest, and that's also very interesting. In typical forecasting, the classical models, classical machine learning. So we have three layers, statistical models, machine learning models, and the new deep learning model. These types of operational problems, classical machine learning models with some sort of feature engineering and certain optimization and mixing strategies, they work very, very well. There could be difference in techniques, for example, what kind of model you're using, but the deep learning models, they often require a lot of data and are not too much flexible or not too much oriented towards the domain. And the models from statistics, they are, I would say, rather naive. So in many computation, and this is, let's say, time series itself is a whole domain, and we can talk a lot about that, but I will stop here because in time series domain, there is a lot of research about using deep learning and model, and AWS has also, let's say, if you check the time series history of AWS, they are using also quite some time series. But this is typical applicable where you have a longer history available, where you have a huge amount of data available from one product or multiple, and where you are also, also trying to forecast on a high level. You're not trying to make it 99% accurate, but maybe starting from 60 and bringing it to 90. So that's why still in this domain, the classical machine learning is doing a good job. Another project that we did is for global routing optimization. So in this case, what we are trying to do is that we have hundreds of stations all over the world. And when you send a packet, let's say something from 3 kilograms or even up to 3,000 kilograms, like a laptop, you want to get it from US or Dell, and it has to come to you. Then the shipment company has to decide that how to route this small, or single shipment. And every day you have millions of those shipments, and you have hundreds and thousands of 100,000 weekly flights. Then you have trucking option. You can choose whether you want to go a direct flight, whether you want to change, what will be the fees of import, and so on. So then how much will be the cost of trucking? Then you have 120 or 220 countries. So DHL is actually operating in more countries than, I believe, United Nations itself. So it has more entities, and there are also some very interesting places that we learned during project like Basel. It's a city that is part of 3 countries. So, how to handle that. Typically, an automated neural network will not figure it out. So what we did in this case is we used, I would say, a lot of custom logic. Pandas and this data frame concept was new. And we developed an optimized solution which would route, which would take an advantage of what is called, let's say, consolidation. This is a logic that how you make the packets together, that you get optimal results, because, to the flights, you are combining packet and you are giving them with their volume or with their weight. And to the end user, you are charging for the box if the packet is fluffy, or you are charging them by their weight. So you can do a lot of consolidation. You can do quite many optimization here. This problem hits this 11 billion. I think now it's a lot more dollar business, and it achieves pretty significant routing, as well as quite some interesting insights. So this is, I would call, typical data analytics projects, where by looking at the data, you can find out quite many trends. I will not go to the video because I will share these slides and you can check the video of this one. This is a very interesting project that we did back in 2017-18. I was working at IBM, and we did implementation of an intelligent smart home. At that time, So what do we have done in this case is, and you will, is that we kind of build a system. You see this small column. So this is what we call, let's say, mini Watson. It has cameras, it has a welcome screen. The cameras are placed here in the whole home. We have placed several sensors, and the objective is that this whole system is able to recognize people, is able to communicate in natural language, is able to act intelligently, which means open the heating or turn off the heating. It should learn the preference of residents, which means that if I am, I go for a coffee every morning at 9, then the system could already start preparing. And this was also connected via IoT platform or Watson IoT platform. It should stay connected. It should be always available. It should be, of course, recoverable, some backup, and ensure privacy. This was the time, I think, the project had a, I don't know, 23rd May or 25th May as our opening date. And a couple of days later, the GDPR hit. So we had to make sure that, and this is a home, which is a showcase home. So it's kind of an office as well as a home for the visitors in this village, which is smart homes for this company. And then when people will enter the home, they should have a ability to be forgotten. So it should just, get this acceptance criteria from the user. So you remember, like if you go now in EU, especially any website, you have to accept cookies. So we had to implement that concept with smart home back in 2018, just before the GDPR would hit, so that we are safe. And it should not annoy, because at that time, a lot of personal assistant type of platform, they were very annoying. So we have used Amazon Alexa, Watson IoT Assistant, and Google Assistant. Their performance has been improved a lot at that time, but in the past it was not as good. So we had to just make sure that its context remains such that it's working just what is needed, and it's not an annoying robot which do not listen to you and which is just suggesting new things. This is also an example which I present when I show the video as what is meant by AI system. So you have many small capabilities that are working together in order to achieve a certain lifetime type of objective. Another project that we did at IBM was about autonomous driving, and basically the objective here, together with the partner, was to learn optimal control over time. So the idea that I had was that we could learn how the car should take small decisions, which it has to take every 10 to 100 milliseconds from the control, so that it is optimizing certain objective. For example, it is optimizing comfort, it's optimizing fuel, it's optimizing time. And for showcasing this solution, we choose time. And that's why you see we implemented it in racing tracks. It's just recently that the cars are allowed to, have go on the roads with some autonomy. At that time, back in 2019, we do not have. But what was interesting, that we use here reinforcement learning. And the concept of reinforcement learning is that the car is basically, have certain actions. In this case, it is like, speeding up, going a little bit right, going a little bit left, and it's learning from the data. And when you will watch a video, you will see that over the time, the car learns how to make a turn more smooth as well as fast and efficient, fuel efficient. Then what we did is that, and this is also interesting aspect of our work, that at Watson headquarters, we have many clients, and we wanted to show them how things work really in reality. So we have a showcase scenario, a lab, and we developed by using small toy cars. The link is also here. You can watch. We built a concept. So we connected it with those toy controls, Xbox controllers. And it's also connected with Watson IoT platform, and it's running a very similar algorithm that we did in the real world. And the challenge we give to anybody is that you try to beat the machine on this one. So we then show that how the car actually had Once it has 15 laps, how much is performance? One is at 150 laps, one is 1500 laps. And then we ask human to compete on different version. And I don't think almost never a human could beat that. And this car has just learned over this platform itself. Maybe for many of you, this could be interesting. This is before Amazon came with Deep Racer. So Deep Racer is a very interesting platform from AWS. Where you can also, use reinforcement learning and have different similar, I would say not exactly same, but some scenarios where you can implement in a more toy type of environment and implement some concept. We tested this in 3 racetracks in Europe, and we also showcased this solution in International Automotive Show in 2019 in Frankfurt. Then we had been working in manufacturing industry. This is, I think, one project that here, and since I had been working on different cloud platforms, in this case with the Microsoft Azure Cloud Platform. This is a project where we implemented industrial computer vision for quality inspection, but also for the whole process monitoring and process optimization for the production of these blades. So these blades are from windmills, and they are offshore windmills, and they're really big ones, not really small ones. So this blade is 100 meters long, and it's roughly 10 meter in its diameter around this curvature, and it has a very difficult structure. And the way you produce this blade is that you have several teams that are working in different regions of the blade, and they have those small fiber glass sheets, very, very thin and nearly transparent, but a little bit whitish and greenish, and then some wood pieces. And then there is a whole program from the production planning that basically tells them that where should be what kind of sheet. And those sheets are, let's say, 20 centimeter up to 60 centimeter wide, and the long up to the length of the blade. This process takes several days, 3, 4, 5 days. And during this production process, a lot of things can go wrong. You can place a wrong sheet type, and if there are small mistakes, like if the edges are not placed within a half a centimeter, this is multi-million product, it can go wrong. And then you have to have all these cost and warranty issues. And so what we did is that we put quite many cameras on top with really good lens, and we implemented a kind of a solution. The architecture is, as you can see on the right side, so we had a laser. So laser is basically guiding where to place, and then the people would place that. And if this placement is 5 millimeter away from the edges where it has to be, the system would create an alarm. Similarly, if you have left some object, if you are using wrong type of sheets, it would alarm and ask to correct it. By doing so, you could improve the quality of your products, and you can save a lot of cost. Actually, rework is quite often in some industries, and you can even optimize. So you just imagine if you digitize this type of solution, what could be, what else can you do? And of course, you need the height is 11 meter, and from 11 meter height, from the 11 to 13 meter height from the floor, you want to see whether a glass looking small sheet is within 5 millimeter of its desired place, and not just like one thing, it's the whole line on a curvature. So we had to do quite some interesting classical computer vision, but also deep learning type of things. And there were many, many roles. My role was as a technical lead and this type of solution designer. And we worked pretty well. We actually got the solution Microsoft Intelligent Manufacturing Award in 2021. And then we have done a lot of, similar computer vision. My PhD was mainly about vision. So I like it or not like it, but there is a huge industry of quality inspection in manufacturing, and there are tons and tons of cases. I have been to let's say in Sweden, even I have gone through the cases where you have these plants where you have all these electronics garbage. and the cars, and they're shredding, and then you put robots there in order to separate. In the cars, you also have this small airbag bomb, so they can explode when you are doing. So you have to identify, you have to separate the metal. So there are tons of cases where you could apply computer vision and automation, and we did it with many different types of industries and clients. And in this case, for example, we use Microsoft Azure because, as you know, IBM is a service company. Fahad also came from there. So and it's agnostic to the cloud that you want to use. And here, Microsoft Azure, Azure IoT, and so on. Also, recently, for a couple of years, I'm working in digital energy. There are many use cases that we are working on. I just put one example here, which is about the data center cooling energy optimization. So it might be interesting for you that the roughly 2 to 4% of world's energy is being consumed by data centers and it's probably going to increase. At least the computation is increasing exponentially, especially now, right? And in data centers, often there is a term called PUE, power usage efficiency. So which is that how much extra power you are using on top of computing power. And it's typically 50 to even 100% more, which is, cooling. Its main component is cooling. You want to keep stuff cool. And then there are different types of data center. There are air, fan, cool. There are more like IoTized ones. But then I was also in some data center, which is, let's say, 11 or 13 floor buildings with the water cooling system. So they can be small, they can be huge. So this solution, we build an algorithm which is basically now learning how to control the speeds and temperatures of fans and the coolant in order to minimize the energy based on the load and based on the future demand of our data center module. And those modules, for example, in one case could be small room size module. In the other case, they can be really large buildings and plants type of data center. We have many other use cases power plants and so on, but I think I will not, because of the time, we will not go into that detail. Also, lately, we have been using a lot of, I'm engaged with this LLMs, the ChatGPT and this type of stuff, for example, for legal advisor, for contents and blog creation, also from in industry, because as you may see, there is a whole AI on the consumer side, but then there is a very much wide area of industrial AI. And industrial AI is typically a bit behind that because it has to first digitize, and there are already set process. There's a mindset, and you cannot, just go and experiment everything. But we are also doing some work for industrial expert bots, which are able to learn from the documents, manuals, the solutions that you need on the fly, how to fix certain machine. And there is, of course, a renewed demand of some operations for IT people like LLM ops, not only for, data scientists. And there is a huge potential. Again, this is just a new field, so we may go. For the sake of time, I'm just getting a bit quicker now. So the typical AI process here, I define how we work, because AI, on one hand, we want to have a product out there, right? In the past, so there are typically two functions. There are many functions. Business is there, but I will just say the two major functions we have is the AI team and the development team. And later, sooner or later, they are going to emerge. It's just that, typically we do some projects where they are high on research. We want to figure out whether this solution is possible or not. Someone can just, come up with an idea. This is where we do, feasibility and proof of concept. But often, if we know that a solution, is now feasible, and for, we can make a legal advisor based on LLM operations, we would rather start with the minimal viable product. And minimal viable product is then where you can actually go and take it and use it and provide it to some people. This becomes then the dev heavy. So this is typically then a combination. We also, in projects, when you manage large projects, you also have to do some people management and project management. So we have come up with some good strategies of combining agile and some data science methods called CRISP And over the time, we have learned, how can we do it quick. Typical range of the projects that I mentioned to you are in few months. Hardly any projects is like years long. So that was, a glimpse of some projects and the areas that I had been working. I was listing down the projects that I did so far. There were more than 70, so it's always difficult to choose and even stop talking about that. So pardon me if I could not take everything I wanted to show there. But now I talk about a little bit about the trends and what could be the future opportunities. So back in 2017, I wrote this article on LinkedIn, a couple of articles where I said, okay, what is data science? So data science for me is basically the domain that is realizing artificial intelligence, right? So you can make a movie called AI, you can make a movie called data science, but technically when you make a department at a organization, AI is so much overused that you want to give it a name. So that's what is, data science is more, the real function, and AI is then what is really the real outcome as accepted by people. So more or less, I will use the terms interchangeably. So what I did is that time I kind of listed I divided it into 4 major dimensions: the data, the technology, the science, and application, and also then different levels of maturity. From data, for example, what is the fundamental core of data? What are different types of, next layer? What is more? Similarly, from the technology, what are the key core technologies, including Excel, yes, people use, and Python, and then, the platforms of machine learning. Similarly, the algorithms, what is really the basics, and it could also serve as a guideline of what kind of, what could be a learning path of someone if you want to be expert in the data science. And then applications. Of course, applications are everywhere, including reporting, predictive modeling, like forecasting, example, natural language processing, like I mentioned, this advertiser, AI system like smart home, RTB engine, and so on. And I think now, starting from 2017 to 23, things have changed. Some things have changed. Data, yes, some change. There are changes everywhere, and I may just go quickly about the trends on each of the 4 dimensions I mentioned. But a major change has come and will have come is with the people and process. Because data science back in 10 years ago, 15 years ago, was a function of data scientists. And now it's becoming a function of whole society, especially for IT industry, more or less everyone. This is also what I will talk. Starting with the data. So the data, I think the major trend about data, I have listed many, but I will just talk about the first 2, which is about, we also have now a trend of making use of vector databases for quick search, Pinecore and so on. And these databases, also we have a trend to use more synthetic and simulated data. There are many companies, as you can see in the middle picture, that provide this type of synthetic data, because often data scientists and AI experts were complaining about the availability of data, that we don't have enough data. So there are now companies that provide data. However, one issue is that, which I can foresee, is that when you use this type of data, there's also chances that you add more into confirmation bias. So in the past, you were having real data, and that was already, had certain bias. But if you generate a lot of machine generated data, you have ability to create a lot of fake content and make them available over the internet, and then influence. And this is what, for example, happened with the board of Microsoft back in 5-6 years ago. It started talking about racism because there was not enough security check. It just learned from internet. Another thing that I would talk, maybe that's about science side. So what has changed? We used to do, neural networks, random forest, forecasting, all those methods. But for last 5, 6, and 10 years, our current model is, yes, there are new developments in classical machine learning, for example, Cat Boost. So now for advertisement engines, there are this new model which are quick and efficient that has been used. Another new concept that we are now getting more and more used to is federated learning, like in our mobile phone devices, it kind of knows that what kind of words we have to use, because it has a local model that is your personal, and then it kind of communicates with the central model. So these devices, the questions are that how can we make sure that our data is still personal, and we are just learning a new updated model of, let's say, Google Android has this keyboard, which is actually updated via federated learning. And we are using these concepts also in industry, where people are very careful. They want to share, for example, let's say we could do data center energy optimization, but we don't want to share the data. We may share some learning or parameters. This is where federated learning is helping. And one very important thing that came now, reinforcement learning is not new. It has been there for many, many years, from 90s or even before. But now it is getting used to more and more. For example, the example of chatbot, ChatGPT, and the autonomous car I gave to you, they were based on reinforcement learning. And especially the OpenAI, they used what is this framework called reinforcement learning with human feedback. So the reason I can say they perform very well from GPT-3, GPT-2, GPT-3 to ChatGPT 3.5 and later on is because of this type of intervention of human scoring. They build a neural network for a reward model for their natural language model, and they use this special algorithm. I think it's called PPO algorithm. In reinforcement learning mechanism, which is improving their model, and that's why the model is still learning. So now we see that reinforcement learning is becoming more and more common. From the technology side, there are many trends. I just listed some trends. I think LLMs, large language models, they are in the trends. And in OpenAI, and also many other platforms, they provide these models now. But what is really let's say my current favorite is this LangChain, which allows you to use the models from different providers, where you can have certain memory and where you can have different types of prompt engineering. You can create different types of agent to solve different problems: chatting, question answering, interacting with APIs, also code generation. I think the trend, and NVIDIA itself has platform for us, but also for big industries to develop, to generate new data. So what I see from technology, and it's also a challenge for AI people, is that 10 years ago, you may get projects like, I want to remove a background, and please do make me an application, or I want to enhance the image quality, or some sort of data matching in natural language processing. But now these applications have got very mature. This is just one example of removal.ai for background removal. In the service industry, this was a task for Ph.D. experts, but now there is already an app. So of course we should use that, and we are using that. Of course, this picture I put only just to say that how much large the landscape is for AI technology. This is a guy, Matt Turk. He published this landscape every year. Please go and check it afterwards. But this landscape is really, there are tons of applications. And if I talk about the challenges in those applications, in consumer AI, in the consumer industry, AI is dominating. It's easy. All the data is digitized, so you can do things quickly. I gave example of autonomous driving. It's still far from the promise, which is okay. Now we have some examples like in Germany that you can do level 3 driving, which means, let's say, you can close your eyes and let the system drive for some time in some use cases in a traffic jam. Industrial AI, on the other hand, is still really, really far from mature. So there is a lot to do. It's open. So I will probably publish in coming days a new article with update. So it really needs this update. Finally, some of my thought. Fahd, is it okay if I take 5 minutes or?
Yeah, sure, please.
Oh, so there's just 3 or 4 slides that I want to talk about the impact. So now, what are the impact and what are the challenges? And I think whenever there is a challenge, there is also an opportunity, and that's so simple. There is a challenge, there is an opportunity. I don't think, AI is going to take over the world right away. We will find ways. And you see the initial robot example. It's still, there is no robot which has this intrinsic curiosity and goal and so on. We will be writing something about it in the near future, at least. So there are three, I think, major school of thoughts about the AI's impact on individuals and society. And one is that where they say AI is existential threat to humanity. For example, there is an author called Yuval Harari, and his book is, and this is a whole school of thought. They think that from the human evolution, now we got some machines which are going to make decisions for us and which are making contents. And that's why they are very, very, challenging to us. And I think partially you can relate to it. Algorithms, when you go to Facebook or Google or internet, technically it's algorithm which are driving our attention. So we are already being driven by algorithm, more or less. There is another school of thought which thinks more about the AI is a threat to individual development. For example, this author Jordan Peterson, and they think, for example, when you have more content that is generated by machines, you get more, engaged with the artificial content, and that could also lead some challenges for our society. And then there is, of course, a huge side which thinks that AI has, like any technological revolution, we have more benefits, like for medicine, for time saving, for making people's life easy. So whenever, you make a industrial revolution, the jobs go away, but it also makes people's life easy. So, agriculture is one of the most difficult things. You have to be 24/7, but industries, you just go for, 40 hours a week. So AI will bring benefits to humanity. I think I can think all of, but I will not give opinion right away. But one more trend that we see is our challenge currently is about laws and regulation. So there is an increased call for regulating AI for fairness, for security, for safety, for accountability. We mentioned that GDPR, which focus more on the personal data and safety. EU is working on an EU Act, which focus on categorizing AI application and then having some sort of solution. So some applications are like, which should not be there, which are very highly sensitive. And many applications could be just high risk. The ones especially which are making decisions for you, which are categorizing people. This is, I think, not yet passed, but the law is there. In US, there are different departments then who are working on regulating AI. For example, this framework for risk management, FDA, the drug authority. You could not think, let's say 5 years, 10 years ago, that they would allow AI solution, but now they have. In many, many cases, if you go to the website, you will see many, especially in the image processing for medical, for X-rays and brain tumor detection, because it's already proven that machines are doing very well, and then you can put somebody afterwards that's just for the double check. And there is also recently a new call from an entity in US, I forgot the name, which has asked industry, and there are hundreds and thousands of individual and industry who has provided suggestions that how to regulate AI. And I think their findings will come quite soon. So this is, I think, my final slide, which is about the roles, how this impact us as IT, people. I think one role that I see more and more coming, because there are more APIs now than the core fundamental research, the left side of the curve I showed you. So a lot of things are kind of mixing together. I think there is a lot of demand for full stack AI engineers who know how to develop an MVP and also have some ideas about AI prompt engineering. Yes, it's I think for short term it's a good thing to do, but for long term it might go more very close to what SEO optimization kind of role. LLM ops. Rebranding of machine learning ops. There are, those special new things like in LangChain, if you go, there are new concepts like agents, the memory that you have to build, the embeddings. So there are some decisions and operations that are a bit different from classical DevOps and ML ops. What is also needed and what are, I think, fundamental is also system level architects of AI, like the smart home I talk about. So you have to, just think holistically. and you should be able to be comfortable with vagueness, and then bring up something which is more clear. And you have to convince the stakeholder. It does not mean that there is no need of niche AI experts. You still need that. There are so many situations where actually you need somebody to tell you that is it correct or not correct and how to get out of that. So it's not going anywhere. It has changed. Like you don't need an expert to remove the background more or less now, but you still need if there comes some trouble. And then, of course, we need these thought leaders and regulators. There is a huge fuss around this. I wish people spend more time with some hands-on and going through examples, and then they talk about whether AI is a threat or not, and how to make an AI-aware policy. Yeah, thank you very much for your patience, and now I stop here for any questions.
Thank you very much. Thank you very much, Shahzad. Yeah, I think we have not much time. Nevertheless, if you have any question, so please feel free to ask.
Thank you so much for the very nice talk. I just have one question. As someone who is mostly a web engineer and mostly focused on the front end side, the back end side, how can someone like me or someone in my position grow into more of an AI role? What path would you suggest?
Yeah, I think now if you're a full stack developer, right? That's if I understand correctly, that if you are kind of full stack developer with the front end and back end, now is the best time. Especially you can choose one niche, and this niche currently is ChatGPT, OpenAI, LangChain, for example. I give you an example because what I see many clients and people who are interested, they don't want to do a lot of research, and even they don't have even time to research, so they want something to be out there. And if you go through their documentation, they have APIs for JavaScript, for Python. Typically Python is very good for those. You will figure out that how quick it is to onboard. So you could choose a niche. There are also, of course, courses online, so many courses. So if you want to do something within 3 months, I would go, okay, take the API, take a couple of examples and market yourself and within your organization. If you have more time, then just I would say learn the courses from Udacity. Also work. This is what I also see one problem. It's for leadership. AI is not right away. You can't become expert of AI. We have made all those mistakes actually. So I just told the success stories, but we would have made mistakes. So if organizations, they should also, I think about, this is what we have done successfully with in Pakistan, also certain mentorship. So good to have a mentor which could lead you. And even if your organization wants to develop something, it's good to have someone who oversees architects and just get you through. Because, as I said, there are so many, the trend is that you can use so many third-party APIs now that if you are just a data scientist who don't know how to program, I would say you are in a difficult situation compared to if you are a full-stack developer who don't know too much about AI, because the APIs are easy to learn compared to programming. So that's what I would suggest.
Thank you for the answer.
Great. So any other question?
Yes, I'm audible?
Yes, we can hear you, Rihan.
Yeah. So Shahzad, you already mentioned that there are different mindsets who think about whether AI is a threat to human or not, right?
Yeah.
So I have had this discussion with my friends that I know AI now is gonna impact our life or take job and all of that stuff, all kind of that stuff. So my question is that every time, we whenever in the past, we have had this evolution, right? Like uh, like there were while there when there were new opportunities were coming, all things got deprecated, right? And which left people, are kind of like, let's say, with no work, right? So like, so this thing will happen, right? It's about, like, it's not, let's say, it's not right there, but eventually it will be that. Like, for example, let's say, when telephones introduced, right, there were PCOs, all across the country. But the moment, like, we received cell phones, and all those people, like, were headbanging, and now we don't have any more business, right? So isn't the same thing gonna repeat, with the AI, more AI tools coming, and because AI can learn faster, as compared to humans, a lot, faster than humans.
Yes. Yes, and exactly. And I think the problem right now, though, it's a very important question, and I also think the same. What I don't think it's not kind of existential threat to us, but on the other hand, it's a big transformation. It's very quick compared to the other transformations. So, every few years it's becoming faster and faster and fast paced. So if the organization has to take decisions, let's say in a certain time in the past, they have to be 10 times faster now. And people also have to adopt a lot. So it will change. Yes. For example, there are many jobs whose jobs are making decisions or creating some contents: journalists, lawyers, tax advisors, even office manager. I had once a case where we had like 10 people discussion. How should we name our new buildings? The meeting rooms, we want to give them certain special names. Okay, you can spend like 3 days of mindful thinking of 5 people versus you can just ask a machine to create several suggestions for you. So yes, this is going to hit, especially in this type of areas, which are quick and easy to optimize. Not all, as you see, there's a whole range of industrial AI which is untapped right now. And but what I hope is that the impact could be short term. That's kind of what has always happened. So people have to get more and more equipped and used to this technology. So if you are a liar, maybe you start using, the GPT, but not in the wrong way, like there was actually a bad case. So many regulations are now demanding that you have this human in the loop. So it may actually be that instead of 40 hours of working, you work for 20 hours now. But there is another issue, if you ask me, which is more, on a holistic society level. Small countries and poor countries, they may be affected a lot because the large model, if you want to customize, you want to train, you want to build yourself capabilities, you need very expensive hardware. And, if you are in a large company or in a very, rich university or organization, you may afford that. But if you are not so much equipped with that and you are playing with small models, small data, the gap is increasing. So there are certainly threats.
So what would be the way out?
Well, that's a long discussion, I think, because it's like it's very strategic discussion. There are countries, there are organizations who should have a good, organization policy. There should be real good investment in people as an organization, even as individuals. So it's even myself. So I had, PhD, I have so many degrees. I have been working like on tons of application, but now in order to stay relevant, I have to make sure that my hands are dirty with this new technology. And I understand, ins and out in order to make sure that we, keep our edge. So people have to, manage individually some time on learning. So this is again a mindset that we are in a very fast mode and it's like, okay, let's get on the train, spend some time. There is also certainly some dust. So it's not like everything is so very well. It could be that maybe 3 months to 6 months later, we start discussing, okay, what works and let's say what does not work. Certainly it's a change. There are more automation. So I would say it's learning, it's investment in time, number one, and it's also investment in policy. That's probably the only way.
Thank you.
Thank you.
Okay, then any other question? I will say that should be the last one. Otherwise, we are already out of time. So if there is any last question, please go ahead. If not, then I will say thank you very much, Shahzad. That was really a very, very informative session. And I think the couple of points which you mentioned regarding the transformation of jobs, like the question put by Rehan, that was super important for all of us to start thinking and building ourselves to continuously learn and evolve. Otherwise, it will becoming hard for many of the jobs which we are doing comfortably right now, probably in the next few months or few years. Yeah. I loved the Watson smart home and the autonomous car. So that was really very fascinating, Shahzad. And I know IBM spent a lot of time and energy on building this, and they are getting some good results definitely out of it as well. I will say it was really, really great to have you to present your journey, to present your learning at Emumba. We are very much thankful to you. Collaborate with each other, and thank you.
So thank you very much, Fahad, for your nice words. And thank you very much, everyone, for having me here.